Welcome to Maths Minders Academy. Today, we are continuing with the IGCSE November 2023 paper 2-1. In our first video, we treated question number 1 to number 13. That is the part 1 of this video series. And we mentioned that we are going to use two videos to complete this variant, that is paper 2-1 variant. So if you have not watched part 1, which covers question number 1 to question number 13, we are going to drop the video link on the description of this video. So you go check it out so that you will follow along. And we encourage our learners, the best way to understand the solutions we are providing is to first pause the video, solve the question, and then check our solution and use it to compare what you have done. By that means, you'll be able to know how much progress you are making. For others that have also asked us to make provision for the question paper, I'm going to drop a link to this question paper so that you can access it. If you check the video description, you're going to see a link to where you can quickly download this question paper. Even the mark guide, you will see everything there. So we are proceeding now to question number 14. If you are new to our channel, please don't hesitate to subscribe. Click on the notification bell so that each time we release a new video, you'll be among the first to receive it. Share this video, go to the comment section and tell us how you feel about our video, and let us know how you want us to improve our teachings, to serve you better. Now let's proceed to question number 14A. This question, we are given this set here. Okay, now this Venn diagram, we are asked to find the number of elements in the intersection of A and B. And you will see the intersection of A and B, we have S plus 5. Whereas we are told that the universal set, the number of elements in the universal set is 52. So what it means, therefore, is that if we add 15 plus 5x plus x plus 5 plus 12 minus x, everything should give us 52. So here, when we add everything together here, we are going to get 32. That's 15 plus 5, that's 20, plus 12, we have 32. 32, we have 5s plus s, 6s minus s. It gives us 5x. And here is 52. So when we proceed, 5x equals 52 minus 32. All right. And then going further, we have 5x equals 52 minus 32 is 20. And so x is going to be 20 all over 5. So s is going to be 4. Now, if s is 4, we look at the intersection, we have s plus 5. So we check number of elements in A intersection B is s plus 5, which will give us 4 plus 5, and that is 9. So we go to the answer space and we put 9 there. So proceed. The B part, we are asked to shade this region where the three sets intersect. So this is the space, the place, the region where the three sets intersect. So that's one mark. We move on to the next question. Question number 15. Now, let's look at this question number 15. Okay. Now, here, it said by shading the unwanted regions of the grid, draw and label the region R, which satisfied these inequalities. So here, we have Y. For this place, we have Y is greater than 1. So we need to draw the line. Need to draw the line of Y. First, we are going to use a line to represent Y equals 1. But because it's a single inequality symbol, we are going to use dotted line for this. So we move on to pick up a line. Okay, Y equals 1. Beautiful. So now, this line here, let's do something about this line. For red, let's increase this line a bit. Okay, and we know it's going to be a dotted line. Beautiful. So it's a dotted line. And the reason why it's a dotted line is because it has a single inequality symbol. Now this one, the second one is line S equals 2. This is where S equals 2. So it's going to be a line that is vertical. S equals 2. So from here, it's going to be a thick line. It's going to be a thick line. So that's the line. This is the line. S equals 2. Then the next one is now this particular one. This is a diagonal line. So what we are going to do is we check the y-intercept is 2. For that line, we look at the y-intercept here. That is, this line cuts the y-axis at a point where y equals 2. So this line is going to pass through this point. Now let's check when S is 0, y is 2, yes. When S is minus 2, y is 0. When S is minus 2, so y is going to be minus 2 plus 2, which is 0. So when S is minus 2, y is 0. To pass here. When S is minus 4, you have y is minus, if S is minus 4, y is going to be minus 4 plus 2. That will give us minus 2. So when S is minus 4, y is minus 2. So we have a line which is going to pass here. And let's check again. When S is 4, y is going to be 4 plus 2, which is 6. So when S is 4, y is going to be 6. So we'll have the line also passing through this. So when S is, we can do one more. When S is 6, y is 6 plus 2, which is 8. So we can see that it will pass here. Now, with what we have done here, we can now pick a line. Let's pick the line. It's passing through this point. Now, let's see. That's very correct. Now, let's see, can we give it, okay, we can leave it as this very color here. Now, let's look at the region. If we look at the first line, the red line that is broken, the region, the required region is above. Y is greater than 1. So every region, of course, if you are going above, you are going to see where Y is 2, where Y is 3. Any number greater than 1 will satisfy this very inequality here, this first inequality. That means any number less than 1 will not satisfy this inequality. So we are going to shed below this line. Any number, because this will be the unwanted region. Any number below this line will not satisfy the inequality. It's only when we have values greater than 1 that this inequality will be satisfied. We share that region. Now we come to this second one here. This second inequality. S is less than or equal to 2. So any number greater than 2 will belong to the unwanted region. So look at it. This is the blue line. Any number greater than 2. So here you have 3, 4. All these numbers are greater than 2. So they will belong to the unwanted region. All the numbers within this region are not wanted. They cannot satisfy the inequality. So we shed them. We shed them. They are the unwanted region. We shed them. Very good. Now let's look at the third one. This diagonal line. Now, let's go and pick a point. Of course, this is above the line, but let's see, is it below or above the line that satisfies this inequality? Let's pick a point above the diagonal line. Let's pick a point like 5. Like 5 is above. Okay, we can pick when S is 1, Y is 5. So let's look at this point here. Does it satisfy the inequality? When S is 1, Y is 5. So we are going to have 5 is greater than or equal to 1 plus 2. Of course, we agree that 5 is greater than 3. So every number above this line satisfy the inequality. So all the numbers below the diagonal line, they fail to satisfy the inequality. So they fall within the unwanted region. So we are going to shed them. They belong to the unwanted region. So beautiful. Beautiful. So we've shaded all the region. So the region that satisfies this inequality is this region here, the whole of this unshaded region. This region that's not shaded, that have the boundary blue line come to the black line, and then part of this dotted line. All these houses here, they are the required region. We write R here and we proceed. So we've actually handled that question. Now, question number 16, we are given the fact that P equals 2W plus 2H. Now, we are told that W is 11 and H is 9.5, both correct to 2 significant figures. Find the lower bound and the upper bound for P. So we take the W first and we look at it. Of course, the upper bound, these 2 significant figures. So this number is supposed to, have 1 decimal place. Should be written, to 1 dp. And the upper bound, of course, is going to be the highest number that can approximate to 11 when I estimate it to 2 significant figures. That number is close enough to 11.5. That is, it's going to be like 11.4999999 ... So that's the number. But of course, writing it, because in bound what we have here is the fact that even the upper band is actually, like, if we write the upper band, what we have is that this upper band is less than, this upper band is less than 11.5. So it's actually approaching it, very close to it. So at infinity, it's approximately 11.5. So we have 11.5 here, and the lower bound, we subtract 0.5, it gives us 10.5. Of course, this is the smallest number that can round up to 11 when we approximate to 2SF. Okay, so we have that covered. Then let's look at the next one is H. We do the same thing for H. We need upper and lower. Remember, this is upper, this is upper bound, and this is lower bound. The same thing here, 9.5. So we are going to add another, we're going to add 0.05 here. So we are going to get the upper bound as 9.55. Of course, the upper bound is actually approaching 9.55. Is supposed to be 9.54999999. Of course, so if you look at it to infinity, it's approximately 9.55. So now, while the lower bound subtract 0.55 here, so the lower bound is actually going to be 9.45. 9.45, the lower bound. All right. Now, with this, we want to find the lower bound and the upper bound of P. So we take P, lower bound. Of course, this is multiplication. So we are going to use the lower bound of W, which is 10.5, and then plus 2 times the lower bound of H, which is 9.45. So this is going to give me 21. It's going to give me 21 plus, okay, so it's going to give 18.9. So when we add these two together, it gives us 39.9. 39.9. So this is 39.9. So we'll do the same thing when we do the upper bound of P. It gives us, for W, you are going to use 11.5 plus 2 times the upper bound of H is going to give us 9.55. So this is going to give me, it's going to give me 23 plus 19.1. And that will give 42.1. So this becomes 42.1. So let's move on to the next question. If you find value in this video and you have not subscribed to our channel, we encourage you to go now, click on the subscribe button, and then become one of our community member. And then go ahead and click on the notification bell, so each time we publish a new video, you'll be among the first to receive it. Share this video, like it, make a comment so that we know how you feel about this video. We love you and we want to satisfy you the more. Question number 17 is circle geometry. This is a chord. CB is a chord, and DCE is a tangent. So let's look at the question now. We have to find S. It says A, B, and C are points on the circumference of a circle center O. Tangent D, it touches the circle at C, Angle BC equals 53 degrees and angle ACO is 20 degrees. Find the value of S. So here, the angle here, this is a minor segment. This is a minor segment. This segment here is a minor segment. So there's a theorem that says the angle between the chord and the tangent is equal to the angle in the alternate segment, which is the major segment. So the angle in this minor segment, of course, we look at where this triangle, is drawn completely. This is the leg of the triangle, which forms the chord CB. Then the other part of the triangle proceed to the major segment. So this angle here is equally 53 degrees. Now we proceed with another theorem that says angular center is twice angular circumference. So we have this angular center, which is twice. That means angle BOC is twice angle BAC. All right, which is 2 times 53. And that gives us 106. That gives us 106. So now we write 106 here. So we write 106. And now we can get this angle here at the back here. At the back here using 360. So we can say reflex angle BOC is equals to 360 minus 106. And that will give us 254. So this side of this angle here is 254. Now, this shape is a quadrilateral. That is, look at the shape here. This shape here, we treat it as a quadrilateral. Of course, it has 4 sides. It has this side here. It has this side here. There's another side, this one, and there's another one here, this one. So we have, let's make this to show it's not equal. So this is 4 sides. So we treat it as quadrilateral. Now, when we add all the 4 angles, that is 1, 2, 3, 4, and we equate it to 360 degrees. So it means that 53 plus 20 plus 254 plus X equals 360 degrees. All right. So when we add everything up there, we are going to get 327. So this gives us 327 plus X equals 360. So S is 360 minus 327. S equals, if you do 360 minus 327, it gives us 33 degrees. So we've been able to get the value of X. So from here, we've seen that S is 33 degrees. We proceed to question number 18. Here, question number 18, we are going to use the sine rule. So here we say sine y all over 8.3 is equals to sine 105 all over 16.2. So here we have sine y equals, if you make sine y the subject, that is 8.3 sine 105. Remember that sine 105 is the same thing as sine 75 degrees. So all over 16.2. So here, sine y equals 0. If we divide this, you have 0. If you use your calculator to divide this, 0.49488. 49488 with your calculator. That means the value of y will be the arc sine of 0.49488. All right. So y becomes 29.661. So because it's angle, we write to one decimal place. That's the instruction. That is 29.7 degrees. So here we write 29.7 degrees. Okay, let's proceed to the next question. That's question number 19. So here are the answers to sketch the graph of y equals cos s. S ranges between 0 degree to 360 degrees. So now what we do here is we get something like 90. We take multiples of 90. Let's say 180. All right, let's get 270, and then we'll proceed. Now, you will see that we are sketching, don't forget, we are sketching y equals cos s. So when s is 0, cos s, if you actually look at your calculator, you see that when s is 0, cos s is 1. Then when s is 90, it is 0. Now, when s is 180, it is minus 1. When s is 180, is minus 1. We sketch it, minus 1 here. And when it is 270, it's going to return back to 0. When it's 270, it's going to return back to 0. Then when it is 360, it's going to 1. So when it's 360, it will be coming up to 1. So we have a sketch, something like okay. So that is the sketch. Now we have to solve for reflex angle. We have to find the reflex angle S. So here, first we find S, taking the cos inverse of 0.21. And so this will give us 77.877. All right. Now, this belongs, if we look at our, okay, this is all, this is cosine, this is sine, and this is tangent. So you will discover that 77.8 lies here, which is positive. Of course, this is 180 minus theta, as this is 180 minus theta. So this is theta. This is 180 plus theta, which is third quadrant. And this is 360 minus theta. So now coming here, for me to get the reflex, I want to get, the reflex angle. Of course, reflex is going to be bigger than 180. And of course, where it will be positive, if you look at the third quadrant, it cannot be the third quadrant because the third quadrant cosine is going to be negative. So it's going to be 360. The reflex angle is going to be 360 minus, which is fourth quadrant, 77.877. That is 282.123. But because it's angle, we'll write 282.1 to one decimal place. That's how far we approximate angle. We approximate to one decimal place. So this is what we are going to get. This is what we are going to get. Now we proceed to question number 20. We want to write this as a single fraction. So this is going to give us, factorize this, 10 is common and s is common. All right, you're going to have x here. Divide 60 by 10, you're going to get 6. So here, if you factorize, of course, you can use 5 and minus 6. Okay, their product will give minus 30 and their sum will give minus 1. So we are going to have something like s squared plus 5x minus 6x minus 30. So you have x into x plus 5. And then you're going to have minus 6 into x plus 5. So this is going to result to x plus 5, x minus 6. So here we have the denominator is x plus 5, x minus 6. Of course, this and this will cross out. We have 10x all over x plus 5. So we write 10x all over x plus 5. So with that, we proceed to the next question. The B part, we also want to write as a single fraction. So we found the LCM of this, which will be the product, x plus 3, 8x minus 1. So when we divide this denominator, this LCM by this denominator, it gives us 8s minus 1. We multiply by 7. So we are going to have 7 into 8x minus 1 plus, if we divide this LCM by this denominator, we are going to have s plus 3. So here we have 5 into x plus 3. So when we open this bracket, we have 56x minus 7 plus 5x plus 15 all over x plus 3, then 8x minus 1. We don't need to expand the denominator. So we have 56 plus 1, 56s plus 5s will give us 61x. Minus 7 plus 15 will give us plus 8 all over x plus 3, 8x minus 1. So we write it here, 61x plus 8 all over x plus 3 into 8x minus 1. So this will be the final answer to this. We proceed to the next question, question number 21. It says, the diagram shows a cuboid, A, B, C, D, E, F, G, H. AB is 15.1 centimeter, BC is 4.5 centimeter, and CG is 9.2 centimeter. Calculate the angle that the diagonal BH makes with the face ADHE. So this diagonal we make this angle. Let's put a line here. Okay, let's give it a color. Okay, beautiful. Beautiful. So now what we are looking for, we are looking for this angle here. So we are looking for the angle here. Okay, now take note that this is 90 degrees here. Okay, beautiful. Now that we know what we are looking for, now we need to get line BH. It's going to be the square root of 15.1 squared plus 4.5 squared. That's the formula. Plus 9.2 squared. So this is the method of finding the longest diagonal. This line BH is the longest diagonal in this cuboid. It's the longest diagonal. And the method of calculating the length of the longest diagonal is simply by taking the square root of the sum of these squares, sum of the squares of the length, the breadth, and the height. Take the square root of the sum of their squares. It gives you the length of the longest diagonal. And that gives us 18. About 18.2455. 18.2455. Okay. Now, so this is known as 18.2455. So if we call this theta, we can go ahead to find theta using sine. So here we say sine theta, that gives us opposite, which is 15.1 over 18.2455. Gives us 0.8276. 0.8276. Final inverse of 0.8276 8276. So here, theta equals to 55.885, which is approximately 55.9 degrees. We write to one decimal place. So here we write 55.9 degrees. Question number 22. You say ABCD is a rhombus with side length 13.6 centimeter. Angle ABC is 41 degrees. BAC is a sector of a circle with center B. DAC is a sector of a circle with center D. Now here, we want to calculate the shaded area. So now let's mark this shaded area with letter M and N. First, let's get the area of triangle ABC. Area of triangle ABC equals half AB times C, which is half our A. Remember also in this diagram that BC is the same as 13.6 centimeters. So we have half times 13.6 times 13.6 times sine 41 degrees. That will give us 60.672 square centimeters. So now that is area of triangle ABC. Now, if we multiply this area by 2, that gives us area of rhombus. So area of rhombus. Area of rhombus is 2 times this value and twice this value gives us 121.344 square centimeters. That's the area of the rhombus. Now, area of the part shaded M. If you look at this diagram now, if I want to find area of the below shaded, I'm going to cut off a sector. Let's look at this sector now. If I remove the whole of this sector here, let me mark this sector. If I cut off this sector from the rhombus, the part that will remain will be the part marked N, letter N. So area, so we need to get area of sector. Area of sector is actually theta over 360 times pi r squared, which will give us 41 over 360 times 3.142 times 13.6 squared. 66.185. 66.185 square centimeters. That's area of sector. So the part marked N, if I subtract area of sector from area of rhombus, it gives me that part marked N. So I can go on to say area of part marked N equals area of rhombus. Area of rhombus, which is 121.344, equals area of rhombus, which is 121.344 minus area of sector, which is 66.185. We subtract that, 55.159 square centimeters. Now, since the part marked N is the part shaded below, and it's the same thing as the part marked M, which is the part shaded above. So the two shaded parts are congruent. So we say area of shaded parts. Area of shaded parts. We are talking about M and N. That's M and N. It's now going to give us 55.159 times 2. 110.318 square centimeter. So we are going to write this answer to 3SF, 3 significant figures. So if we write this answer to 3 significant figures, it becomes 110 square centimeters. So we go and enter 110. Already there is a unit here. The square centimeter is given. So that's how to find or solve problem involving area. So that's how to get it. So this is how far we come to the end of today's tutorial. We've been able to exhaust all the questions in Igcse paper 2-1 of November 2023. If you find this video impactful and you have not subscribed to our channel, go ahead and click the subscription button, click on the notification bell so that when next we publish a new video, you'll be among the persons that will get that video first. Share this video if you have not done so. Like it, go to the comment section and tell us how you feel about this video. In our next video, we are going to look at paper 2-2. And of course, we also have opportunity to look at paper 4-1. This is a variant. This is 2-1, and variant 2-1 goes with 4-1. So we are also going to look at paper 4-1. Why not check our channel from time to time to see when we release the video tutorial of the next paper. We love you. We are looking forward to seeing you in our next tutorial class. This is Maths Minders Academy saying goodbye for now.
beneath the sky painted with dreams. We're chasing the echoes of silent screams, caught in the spell of the cosmic night, where fantasies bloom in the pale moonlight. We'll let go of all that we know and dance in the stardust's gentle flow.